For this lesson, we're going to look at inverse relations and inverse functions. Now, an inverse relation is basically where the input and the output swap places. So our objective is to be able to do inverse relations, find the inverse relation when we have ordered pairs and when we have formulas. So first of all, let's go ahead and give some information. For an inverse relation, the input and the output, usually it's the x is the input, the y is the output, will swap places. So they change. You have the x and the y. If this is x, this is y, they'll switch places. Now the inverse will undo what the original did. Now, we know a lot of inverse functions. Like for instance, if we add 5, to undo that we would subtract 5. If we would multiply by 10, to undo that we divide by 10. Those are inverse when it comes to operations. We want to do the same thing with this. So for instance, as this example here, here's the original. 10 is the input, the output is 100. This would be like if I square something. So this would be x squared. So if I square 10, I get 100. If I square 15, I get 225. If I square 20, I get 400. Well, if I want to undo that, I would square root it instead. So if this now is my input for the x, to undo what I originally did, I would square root 100, I get 10, square root 225, I get 15, square root 400, I get 20. I get the original inputs because it's been undone by my inverse. So let's take a look at what that means with ordered pairs. It's a pretty simple process with ordered pairs. If these are my x's and y's, you're just going to list them for the inverse by having them swap places. 22 becomes the first, the input, and 34 becomes the output. For the next one, 5 becomes the input, -3 becomes the output. The x and y swap places. Here, the -1 becomes my x, and my 17 becomes the y, and then lastly, 8 becomes the first member, and then the second member swaps places with it, it becomes the 0. So when you're doing an ordered pair, just have each x and y swap places. It's as simple as that. Now, if we're dealing with a formula, we want to use these steps to work it out. First of all, if I'm using function notation, you're going to replace the f of x, which in some cases it might be g of x, but whatever the function is, replace f of x with y. So we want to put it into a formula that we can just deal with the x's and the y's. So on this one, all we're going to do is we're going to make it y equals 2x minus 5. Okay, it's as simple as that. Just replace the f of x with the y. The second step is we're going to do like our inverse tells us, we're going to swap x and y. So notice what I'm going to do here is I'm going to have x be where the y is, and I'm going to have y be where the x is. So I'm going to have x equal to 2y minus 5. They swap places. So I'm going to put a little arrow here because this is where I do the inverse step. I have them swap places. Okay, and then lastly, we're going to solve for y. We're going to get y by itself. Okay, so when I've got this x equals 2y plus minus 5, I want to get rid of the minus 5, so I'm going to add 5 to both sides. So x plus 5 equals 2y. And then I want to get rid of the 2, so it's 2 times y. I'm going to get rid of it by dividing by 2 on both sides. So I get x plus 5 all over 2. So this is my inverse formula. Now the formal notation for it, since this is f of x, the formal notation for it, and we gotta use this new notation, is to put a little -1 up there. So f -1x, that means inverse function of x is going to equal my new formula, x plus 5 over 2. So this is my answer to that problem and the notation I use for it. All right, let's do another one here. Let's do this g of x. So the first thing I do is make it y equals 5x plus 15. The next step is I'm going to do the inverse by having the x and the y swap places. That's the act of making it the inverse. So x is going to equal 5y plus 15. Now you got to get the y by itself. So I'm going to subtract 15 from both sides. And then to get rid of the 5 times the y, I'm going to divide by 5. So x minus 15 over 5. So my formal notation for it is I write the inverse with this g with a little -1 of x, that means inverse of the g function, is going to equal this formula, x minus 15 all over, and that should be a 5. So we'll make this over 5 for my formula. Okay. So there we go. That's how you do it with formulas. Follow the steps of making it y equals, swap the x and y, solve for y, like a literal equation like we've done, and you've got your answer. Now just some more insight just to what this looks like graphically. If I've got a graph of something, and let's say this point is 0, 5, and this point here is -1, 0, and I want to do the inverse of it, remember all you have to do is swap the x's and the y's. So over here, to do the inverse, what I'll do is I'll swap the x and y, and that gets me out to 5, 0, because they've swapped places. So I'll put a point there, and then this -1, 0, I'll make it 0, -1. So here's 0, -1. There's that one, and I draw the line between those. This is the inverse graph of this one. What it is, for an inverse graph, what happens is it's a reflection over the line y equals x. It's y equals x because the x and y are swapping places. So you do a reflection over y equals x, and the way you do it, this is the key step here, is you just take ordered pairs and you swap the x and y in multiple ordered pairs until you've got the shape of the graph. Here we did it with 2 points and we were able to draw the reflection line. All right, so what we've done is we've looked at what inverses are. Inverses will undo what the original did. And the way we do it in the general case is x and y, the input and the output, swap places. To do that with ordered pairs, you just literally take the x and y and have them switch places. When it comes to formulas, you go ahead and make it y equals, and then take the variable x and y, have them swap places, and then solve for the y, and then we found our inverse.